Hi students, this video is on AMS tutorial question C3. Alright, so one look at this question, you will know that it is a back titration question because two reactions are taking place. So even if there is no hint, okay, so this part is the hint for the question, it will not appear in the question if it appears in your exam. I mean, it will not appear in exam if this question comes out in exam. Alright, so even without this hint, you should know that two reactions are taking place. So reaction number 1 is between NaOH and either ammonium chloride or sodium chloride or both ammonium chloride and sodium chloride. But in this case, you will know that reaction 1 is definitely not between sodium chloride and sodium hydroxide because sodium chloride, you know, that is a neutral salt, so it will not react with your base. Okay, another hint given in the question that it must be reacting with ammonium chloride is because it says that ammonia gas was evolved. So ammonia gas was evolved directly links to ammonium chloride, so it must be a reaction between NaOH and ammonium chloride. And also ammonium chloride is NH4Cl. So the NH4Cl, in the presence of water, the NH4 plus can actually produce H plus, and therefore it can act as an acid, which will then react with your base, okay, to give you your salt and water. Hence, your reaction 1 is actually NaOH plus NH4Cl to give you NH3 plus NaCl plus H2O. Alright, you know that ammonia is evolved, therefore NH3 must be produced, and you know that a salt must be produced, so NaCl is produced. Okay, so this is reaction 1. Next, for reaction, before I go to reaction 2, first, in reaction 1, you know that for back titration, one of the species, either NaOH or NH4Cl, must be in excess. So in this case, if you read the question carefully, it says that no more ammonia was evolved. So if no more ammonia was evolved, it's actually giving you the hint that no more ammonium chloride is present to react. So ammonium chloride must be the limiting reagent, and therefore is used out, and hence without ammonium chloride present, even if you have NaOH, ammonia gas will not be evolved. Okay, so your sodium hydroxide over here is actually the excess reagent. Okay, and then for reaction number 2, if you read, it says that the residual solution was made up to 250 cm3 and 25 cm3 of the solution required this volume and this concentration of HCl. Okay, so you know that for back titration, reaction 2 is always a neutralization reaction between an acid and a base. So even if you don't know that NH4Cl is acting as an acid, you know that HCl is an acid, and therefore it must be reacting with a base, and you sure know that NaOH is a base. Therefore, reaction 2 must be a reaction between HCl and NaOH. Okay, to give you NaCl and water. Okay, so now, if you look at the question, the first thing that you can immediately do is definitely to find the initial, I will use highlighter, the initial amount of NaOH that is used to react with your ammonium chloride, as well as the amount of HCl used for the titration reaction. Okay, so from your initial amount of NaOH, this A over here, you should be able to find that the initial amount of NaOH is actually 0.2 moles. Okay, so this one, according to the steps that I've given you, to do a back titration question, you should calculate the known amounts first. So you should calculate the initial amount of NaOH since they give you the volume and concentration, and the amount of HCl used for the titration. So using your B, you should be able to find that the amount of HCl used for the titration is 0.0112 moles. Alright, okay, and then since you have reaction 2 mole ratio between HCl and NaOH, which is 1:1, you know that the amount of NaOH used in your titration, this one, is also 0.0112 moles. And here is the catch in the question, which I'm sure most of you made this mistake. Okay, so the question says that the residual solution was made up to 250 cm3, and 25 cm3 of this solution required this amount of HCl, which means that this 0.0112 mole that you use in your titration, this amount is only the amount in your 25 cm3, because out of the 250 cm3 of the residual solution, residual means the resulting solution from your NaOH and NH4Cl reaction in reaction 1. Okay, out of that resulting solution, only 25 cm3 of the solution was being used for the titration. So if you recall, once you transfer the solution, the amount also changes in a proportional manner. Okay, so in 25, so 0.0112 moles is in 25 cm3. So therefore, you should find the amount of NaOH present in 250 cm3. Okay, so if 25 cm3 is 0.0112 mole, 250 cm3 equals to 0.112 divided by 25 times 250. Alright, and you should be able to get 0.112 mole in 250 cm3, okay, of NaOH. And since you have now the original amount of NaOH, which is your excess reagent, okay, so your original amount, which is 0.2 moles, and the amount that is in excess, which is 0.12 mole, you will then be able to find the amount of NaOH that has reacted. So you will take 0.2 minus of 0.112 mole, that will be the amount of NaOH that has reacted. Okay, so using the mole ratio of NaOH with NH4Cl 1:1, the difference is actually the amount of NaOH reacted is equals to amount of NH4Cl that is present in reaction 1. Okay, and with the amount found for NH4Cl, you will then be able to find the mass of NH4Cl, and therefore you will be able to find the mass of NaCl, because your 5 grams consists of your NH4Cl and NaCl. So if you minus off NH4Cl mass, that will be the mass of NaCl present in your 5 grams. Okay, that's all.